going to move on to a topic where we're looking at applications of differentiation. So previously, we've learned how to differentiate lots of things. We've done basic ones from the formula sheet, then we've done the product and the quotient and the chain rule. And we've actually done one application already where I talked to you about tangents and normals. What we're going to do now is have a look at some more applications, so some more things you can do once you know how to differentiate things. And I'm going to go back to the very first thing I talked about when I was doing this topic. The video was called something like Why Do Calculus? And we had the idea that if we had a curve in general, and the points that we're really interested in were this point up here and this point down here. And I think I talked about a car and having velocity up the side and time along the bottom. And we talked about it being the top speed, and then it slowed down again, and then it came to a give way, and it bottomed out, it slowed down, and then it sped up again. This one obviously speeds up quite a lot and doesn't show any sign of slowing down once it gets past that point. But this sort of curve, and asking the question about how can we identify these 2 points. Okay, and the thing that is really critical about these 2 points is the slope at this point. So here, the slope is flat, and here the slope is flat. So both of these 2 points, the slope, which is what we get when we differentiate, is equal to 0. So the key idea here is that at turning points, the derivative equals 0. That's the essence of this application. If you've got that, then the rest of it sort of follows. And there's usually a mark in an exam for writing down something like that. So if you see a question that's got maximum or minimum mentioned, get that in. Okay, so in terms of maxima and minima, this point here is a maxima, or maximum, local maximum, and this one is a local minimum. Spot them both right? Awesome. Okay, and to find out where they are, you differentiate, make the derivative equal to 0, and solve it. I'll do an example shortly so you can see what's going on. There's also one other interesting point, which is where what's called the concavity changes. So this piece is concave down, it's got the bowl facing down, and this piece is concave up. And there's a point in the middle here somewhere. This is what we call a point of inflection. And that's also a point that we sometimes are interested in, where the changes from being bowl down, concave down, to concave up. The other question of, when we do one of these things, we can work out where the maximum and minimum are by solving this problem, but quite often we want to know which one we've found, and if you can't draw the picture, it's not always obvious which one you've found. So there's a test for that. So once you've figured out where the turning points are, then you can test which is which. So maxima occur where the second derivative is less than 0. Okay. So the second derivative is how the slope is changing. And if you look at this point here, on this side of it, the slope is high and positive, so it's a big positive number. And then here, it's a small positive number. And here, it's a small negative number. And then down here, as it gets steeper, it's going to a bigger negative number. So the slope is changing from highly positive through a little bit positive, through 0, to a small amount of negative, to a lot more negative. So the slope's going from big to small. So the change of slope is negative. So the second derivative is less than 0. And that shape gives us a maxima. And likewise, a minimum, or minima, plural, occur where the second derivative is greater than 0. It's the same thing on this point. Slope starts off negative, big negative number, lesser negative number, 0, a little bit positive, a lot positive. So it's going from negative through 0 to positive. So the slope going around here is increasing as we go through here. The slope is increasing, so it's greater than 0, increasing. And the point of reflection occurs where the second derivative equals 0. Okay, so that's the point where the rate of change of slope is the same. So through here it's going to be straight effectively. Okay, so we've got those three different things that you need. The ones that are really important here are those two. Because the typical question is going to say something like, given this curve, find where the maximum and minimum are and identify which is the maximum and which is the minimum. Okay, so that's just the theory, and in the next video we'll show you how to actually go about doing it by looking at an example.